Okay, so now we're going to go over the examples from 7.3 on rectangles and squares. So let's start with the properties that we know about a rectangle. So first thing, again, everything with a parallelogram. I'm just going to say all parallelogram. And then the two new key properties we have with a rectangle. First one is that we know that all angles are right angles. So the angles that are actually part of the rectangle themselves, not the angles formed by like the inside triangles or anything like that. And then we also know that the diagonals are congruent. So those are those two new key properties that we know. So let's start. So we're given that RPS here, 62, and then we're given that QS is 18. So let's start with QPR. So angle QPR is this angle right here. So I know that angle P is a right angle, so it's 90 degrees. But here I already have 62 of it from angle RPS. So I know I got 62 plus whatever QPR is, that's got to get me to 90. So from that, we get that this is a 28 degree angle. Because again, that's what's going to make angle P a right angle. So we got that. Next one, I want to know what's PR. We're given here that QS is 18. And working with that third property that diagonals are congruent, that makes PR also 18. Angle PSR. So if I'm looking at PSR, that's this whole angle here. We know that all angles are right angles of a rectangle. So that makes that 90 degrees. ST, if we're given that QS is 18, we have all of our parallelogram properties, so our diagonals are still bisected. So that means that ST is going to be 9. Again, that's just half of 18. And then if I want to know what's PTQ, remember we did not do this example, so you do not have to worry about that. That's getting into isosceles triangles, and we're not going to touch that. Okay, so there's rectangle. Let's get to square. So, 3 things about a square. We have all parallelogram properties. Then we have all rectangle properties, and then we have all rhombus properties. So basically everything that applies to all 3 of those applies to a square. So let's start. I want to know what's the measure of EJF. So remember, first thing, all angles are either 45 degrees or 90 degrees. And that will always be true in every single square. You will always have either a 45 degree or a 90 degree angle. So if we're looking at EJF, if I look at EJF, that's this angle right here. Working with what we know about a rhombus, we know that diagonals are perpendicular. So that means that EJF has to be 90 degrees. It's going to be 90. So let's go ahead then, let's talk about EJ. So we're given that GJ is 15. Diagonals are bisected. So that makes EJ also 15. So that has a length of 15. The measure of angle EFH. So if I'm looking to EFH. Oh, drawn that wrong. That's EFG. EFH is this angle here. So EFH is right up here. That is half of the entire angle of the square. We know that the whole thing's 90, and we also know that the angles are bisected. So that means that angle EFH is going to be 45 degrees. Again, because it's half of 90. That right angle of angle F, which is 90 degrees. FH, so we know that diagonals are also congruent. So if the entire thing, EG, is 30, that also makes FH 30. So that 15 plus 15. And then the measure of angle FGH, so if I'm looking at FGH, that's the entire angle G. We know that all angles are right, so that gets us a 90 degree angle. So there's the example of that. What I want to do is kind of a quick little breakdown of the angles of a square. Just because I know that there's been a little bit of trouble with that. So angles of a square are always set. So you always have that the entire thing's 90, so you've got 45, 45, 45, 45, 45, 45, 45, 45. And then all the angles formed by the diagonals are 90. So 90, 90, 90, 90. So the angles are always set. It's just what changes is whatever the diagonal length is, or the piece of the diagonal, or whatever the side of the square is.